last lesson we did addition. Now we are going to do some subtraction and related problems. So recently I like nature, and recently I took these pictures maybe 2 days before. What do you notice and what do you wonder about this picture? Go ahead and tell Esma.
Like the 7 sheep, and we're like gonna minus some of the sheep.
Minus 7. Oh, you want how many legs? How many legs can you count? Yes. Yeah.
I couldn't count all of it,
But what operation we can use?
Addition. You could just count all the sheep legs,
Addition.
or you could use multiplication.
Okay. Oh, I can see. Oh, yes. Yeah, we can use addition, count total number of legs. We can also use multiplication, but you have not learned multiplication yet. Multiplication means so you can, let's say you have 7 sheep and each sheep 4 legs, in this case 4 times 7, but you have not learned yet, but we will be doing more multiplication later. Okay. So last couple weeks we did which one doesn't belong warming up activity. Now we are focusing on its open middle types of activity. So open middle, let me explain open middle activity. Open middle activity is a open. So you can, let's say you can try, and you can numbers and anywhere between 1 and 9. So let's see, you are going to use numbers 1 to 9, but each time you have to use at most ones, each time 1, and you need to create the smallest possible difference. We need to create the smallest possible difference. So let's see, but you have to use only each number once. It's kind of interesting problem, but this is we may come back this problem later, but this is a very interesting problem, and then I will maybe go back and visit this problem end of this session. Before now, last time we did addition, right? Instead of using standard algorithm, we can use ways to put numbers. One thing. Now we are by the partial sum. How do we use the partial sum in this case?
I think you just use expanded form for partial sum.
So when you say expanded form, we use place value ideas, right? Expanded form. Ones, tens, and hundreds. Can you explain further, please?
Well, like by standard form, I mean like you would be like 300 plus 800 equals 1,000. 100. 1,100 by like you would just like put it in a big one.
Okay, yeah, you first focus on hundreds. In this case, you have 300s and 800s. 300 plus 800, 1,100, which is 1,100, right? And you have tens, 50 and 40, 90, and you have ones. You have ones is 6 and 7, 13. Then you add them together, right? So 190. So 190 plus 13. So 100 So 1,100 plus 90, 1,200. No,
So are you asking the answer of 1,100 plus 90?
yes, 100. Yes, now go ahead.
1,100 plus 90 plus
Yes.
13 equals 1,203.
Okay, great. Yes, 1,200. Yeah, that's the what we call the partial sum. So, well, this is interesting problem. You don't, so when you see this visual, what comes to your mind? Nothing, right? There is no numbers. There is no numbers over there. This is actually, I'm going to write something interesting. This is actually operation. We are doing operation. What kind of operation do you think this? I remove the numbers. So, sorry, what do you think?
Well, the operation you're doing is probably regrouping.
Regrouping. That's interesting. So why do you think this is regrouping?
Because like you're taking a 10 because you like for the problem, let's say you had to subtract 7 minus 8. You don't have enough.
So
You
number,
don't
I don't have a number,
enough
right?
of 7 to subtract 8 from 7. So you just take a 10, cross it out, make 10 ones.
Okay,
And
okay.
then you
Okay,
have
let's first think about this. I have 4 and this is 400, right? And let's figure out my first numbers. 400. What would be my the first number is 10 digits. 1, 2, 3, 4, 5, right? 50. What do you think my other one digit number? So my first number is ones digit. Is it going to be 400 what? 50 what? 59 possibly, or 58. Okay. Okay, my first number, but this is a little bit challenging, but I'm going to say my first number is 458. What's my second number? What number am I going to take away from 458? Possibly, yes, Esma?
100.
Oh, there is, because do you see that there is I am crossing how many numbers? 9, right? Is it, am I crossing 9? 8 here, 1 here, 9.
8.
That's why this has to be 9, right? How many rods, how many tens am I crossing? 2, right? Possibly 2, right? And how many flat, which is in this case 100, am I crossing? 1. Okay.
1.
Okay, let me explain. Okay, that's the first challenging part. That's why I just want to rewrite the numbers. What the operation are we doing? So now, are you ready to see how standard algorithm works? So here's my first question. What is my first question? 9 is bigger than 8. What should we do, Sari? Yes, please.
You should take a 10, aka the 5, and make 10 ones.
Okay, it's called regrouping, right? Or decomposing, right? So you are kind of borrowing, right? Is it called borrowing? But now you understand. So because you are making one of the 10 and into what? One of the 10 into small ones, right? Tens, which is one this is going to be 10 plus 8. Now you have 18, right? Okay. Then what's next step, Esma?
Minus the 10.
Minus, okay, then that's okay. But you have now 18 small cubes. Now you have 18 ones. Then since you have 18 ones, minus how many you need to cross out? How many you need to take?
8.
Cross? 8 or 9? 9, right? We are taking 9 away from 18, right? Because you said 8 plus 1 is 9. Then what's left over? So 18 take away 9, left over is 9 pieces. So then how many, since one of them is already gone, right? How many rods, how many
Yeah.
tens do I have?
2. 2.
Oh, but it was originally 5, right?
Yeah.
Yes. Oh, so you mean that we are going to cross 2 of the tens, right? Then you cross 2 of them, because 4 take away 2 is 2, right? Then what about
And
this
then
one? You
a
cross
one
another,
more.
and
Hmm.
are we okay? Do you guys agree for this operation? So what I did, I visualized, right? I visualized this operation, right? And then we all understood why we are borrowing and what happens when we borrow numbers from neighbors. Yes, sorry.
When you borrow your numbers or take the numbers,
Hmm.
then it makes it possible to subtract the number that you can't subtract.
That's a very good understanding. Thank you for explaining, because you decompose one of the tens and you make 5 into 4. You 4 now you make the 50 to 40, but you decompose, you regroup one of the tens and you make these ones 18. Then you can now do 18 minus 9. That's great. Great. So that's why that it's good to learn standard algorithm, but we need to also learn how standard algorithm works, right? That's a good starting for this operation now. That's great. So, but sometimes children's they are doing differently than what we learn a regular standard algorithm. Now take a look at this problem. 364 minus 79, and this student is doing interesting way of doing subtraction. What do you think? How do you think this works? Can you try to understand these students, the second grade students' work? Yes, Esma.
I think first he borrows the 10, then he like adds it to the 1, then he minuses 9 from 14, and then he gets 5.
Well, yes, but why do you think there is a minus? Manamuk, what do you think that this minus means for us? Or negative means? This is interesting, right?
Like subtract a number, like
Mhm.
like
Because
take it,
9 is bigger than 4, right?
Yeah.
That's why maybe it makes negative 5, right? And this is actually what, 60, right? This one is 70. Then 70 is bigger than 60. That's why it makes negative 10 possibly. And
Yeah.
this is 300, and you put 300. Then what's next?
Following
How-
a 10?
Yeah, how do I get 285? How do I get 285? Because, okay, who wants to explain how do I get 285?
Oh,
Yes,
no,
Esma.
no, no.
Yes.
I don't know.
But
I
Esma,
thought I looked.
you have 300, right?
Yeah.
Take away 10.
290.
Take away 5.
285.
85. Yeah, this student's done is different than what we learned, right? Now he is thinking that, well,
Yeah.
9 is bigger than 4. Therefore, I can say this is negative 5. And 70 is bigger than 60. Therefore, I can make this one minus 10, right? Is because it's bigger. That's why I can take away from 300 minus 10 to 290 minus 5, 285, right? That's a little bit different ways, but we need to understand also our friends' work, right? To boost your operation idea, so concepts. In this case, subtraction we are focusing on. Now, do you see that 923 minus 65? And I'm asking this another one, n minus 100. Now I'm saying that this calculation gives the same answer. What do I mean the same answer? 65 that equals to n minus 100. What is n? So, and what is the connection between these two, right side and left side? What do you think? How do we get the value of n? So do you see that the connection between 65 and 100? What do you see this 65? What is the difference between 65 and 100?
N.
65 and 100.
Oh.
30?
35.
35. So you put 35 to this guy. What is the then what is the value of what's the value of n? Think about the value of n. So then the difference between 923 and n, what do you think the 900? So let's think about this one. So there is, think about this one this way. Okay, well, 23 minus 65. You make this one, you make this one 100. You add 35. What happens when you add 35 to 923? What's the 923? Yes, Sarah.
It becomes 950. 958.
And this is going to be the value of n, right? 958. So do you see that there is a difference between these two numbers should be same, right? Then how can you keep the difference? Because you add this first, you add the second number 35, you have to add also the 35 to 923, right? A little bit different than what you are learning in your school, but still understandable, right? Because we are keeping the balance, keeping the difference same. How do we keep the balance the same? When you add the one number to 35, you have to add the first number as well. But there is a name of these two numbers. It's called subtrahend and minuend, but you don't have to know that name. Okay. So let's take a look at another problem that helps you understand standard algorithm better. Now, there is a 3 unknown number, A, B, and C. So we need to figure out A, B, C. But we have to use our subtraction idea, right? We need to understand how can we get B? What would be the possible value of B first? Okay, let's think about that one. What do we do when we do subtraction? B is bigger than 2, right? What do you think B would be? Can B is 1? No, right? Can be 2? No, right?
Yeah.
3? No. What about 4? No. 5? Esma, why B is not 6? No, it's not impossible, right?
Yeah.
What about B? B can be 7, Esma? Namık? No, 7, right?
Yeah.
What about 8? What about 9?
Maybe.
9 is the best candidate, or best why? Why B is 9?
Is it the highest digit number?
That's not the only reason, because 9 is bigger than 2. What do we do? Esma, what do we do? Borrow. Yes, sorry.
Yeah.
I was gonna say the same thing.
Yes, borrow. What happens when we borrow?
Well, you take away whatever number is bigger. In this case, you take a 10 and make 10 ones.
Which is 12, right? Then 12, take away 9. 12 minus 9 is what? 3. Now everything is work. Everything is work. Then B equals what? 9. Do you now understand the value of B must be 9? We understood, right? Good. What do you think about A? Now think about A. What's the value of A? It's not 8, right?
No.
It's not 9.
No.
Or what should A be?
Maybe like a lower number because it's like the first.
That's exactly, you're right. So let's say lower number means, what about 5? If we pick 5, what happens when we pick A is 5? If A is 5, then you borrow one of the 5 and you become 4, right?
Yeah, and there's 7 and 2 next to it. And 7 minus 2. 2 minus 7 equals 5.
Do you think that is going to be work? 5 is not really work. Is not working, right? What about 5? Not 5, maybe. What about 6? What about 6?
Yes, I think.
Why?
Yeah.
Now, can you explain why A must be 6?
Wait.
Because when you have originally 6, then Namuk, you borrow one of the 6, right?
Okay, come on.
And it becomes 5, right? Then 15 minus 8. What's 15 minus 8?
7.
7. That works, right? Then A has to be 6. Then what is this? You borrow one of the 7. Then this becomes what? 6. 6 minus 4.
2.
So C, it has to be what? 2. What's my number? Let's try to get check the our work. 600 what? So 700.
762.
2 minus what?
Minus 1.
489.
Let's do one more time. 12 minus 9, 3. This is 5. 15 minus 8.
15 minus 8, 7.
Yes, Namik.
I'm looking for a pen.
Yes. Therefore, this is 6. Yes, go ahead. 6 plus 9 plus 2 is going to be what? 6 plus 9, 15 plus 2, 17. Is it, do you think this is hard for you? But we handle it, right?
Yeah.
That's okay to see the challenging problem, because you know the concept, right? You know how to do 2-digit or 3-digit subtraction. Therefore, you can engage some challenging problem, right? That's okay to get this challenge, but we handle it and you understood. That's perfectly okay. Are you guys? We are about to. So now I am going to show you a very interesting problem related to a little bit doubling and minusing. So here's a question. There is a function machine, number machine. It's called a number machine or function machine, number machine. So you put a very interesting magical machine you put input a number and you double it. You double it and you take away 3 from there. You double it and you take away 3. So no, none. If you Sarah, if your input is 10, what is your output? You double 10. Sorry.
Your answer would, I mean, if you double 10, that would be 20. And then you from 20, you take away 3, and that would be 17. So
17.
your answer is 17.
That's correct. That's good. This is called function. Now you are learning function. That's great. So Namu, can you tell me, please, if your input is 16, can you help me to understand my output?
16 plus 16 equals 32. Minus
Okay,
3,
double 16, 32. That's great. Minus 3, take away 3.
29.
29. You are perfectly right. Now you are kind of learning function. The function has, right, you can see that input and output, right? You are now learning function. It's very good for you to learn soon coding. When you do coding, you learn input and output, right? Yes, sorry.
I do coding on this app.
No,
Yeah.
okay, that's great. So have you
But they're like
have you heard input and output? Because when you do coding, the something comes up, it's called output, right? Your output. So you'll learn further later. So now the third one is very interesting. It's challenging. Now I didn't give you input. Now I gave you output.
Oh.
That's interesting. Now you multiply by 2 and you take away 3, but your input is 7. What is your, sorry, your output is 7. What is your input? That's interesting. How you go backward? How you go from output to input? What number should you enter to get this result, this output as 7? Would you want to try a different number, Esma? Possibly, yes. Do you want to try any number? We can do always trial and error method, right?
9.
9. Okay, let's try 9. You said 9. I am going to put 9 here. 9 times double 9 is what? 18. And take away 3. No, that's not working, but that's a good try. Thank you. Let's try a different number. 9 in this case doesn't work, so that's okay. What number, Sarah, what number would you like to try?
You could try 5.
Okay, let's say 5. Double 5.
Yeah.
10.
10. 10 minus 3. Yes. Yay, we got it. Great job. Thank you. So that's great. And our final number puzzle will be today. It is interesting, but okay, let's do this one and I will give you homework for the rest. So this is a good number game. So we use 1, 2, 3, and 4 only. And we use 4 operation. 4 operation means multiplication, addition, subtraction, and division. You don't have to use division, but now we want to get all first 5 numbers. Let me explain how do we get, so 1. So how do you get 1? So what is, okay, I can think of 1. What is 2 times 3? Do you know the 2 times 3? 6, right?
Yeah.
Yes. And I can use 1 and 4. And what's the 6 minus 5?
6 minus 5 is 1.
1. Do you see that I got 1 using this method? Can you try now can you try to can you try to figure out number 2? Yes, Namık.
Maybe
Let's do that. Let's try something. Maybe 1 plus
4.
1 plus 4. That's a good idea. I like it. You got 5, right?
Yeah.
So what number, Namık, you need to take away?
5.
3, right?
Yeah.
You have not used, so 1, 2, 3, 4. You use 1 and 1 and okay. That's interesting. Possibly.
Oh no.
Yeah. Oh, that's okay. That's okay. Can we go maybe, Namık, 1? Oh, 2 plus. Okay, let's.
Yeah.
Can we go 2
2
plus 2 plus 4? 6, right?
6 and 6 minus 3 equals 3.
And then, oh, this one, right? Very good. And then 6 minus 3 minus 1 becomes 2,
3.
right?
Yeah.
Yes, that's great. We got it. Okay, let's try to figure out number 3. Let's try it. It's a good number puzzle, nice number puzzle. We can do that. Okay, how do we get number 3?
Two plus 4.
2 plus 4, then
Minus 3 equals 6.
okay, 2 plus 4 is 6. And then what about this one? What about what's 1 times 3?
3.
And then this is also 3, right? So there is multiple ways to that. So, and what about 4? So how do we get 4? And then we will get 5. Okay, when you add, so how do we get 4? Okay, think about 4. Okay, let's see. 1. What about 3 plus 4? 3 plus 4?
3 plus 4.
7. Yes, sorry.
Then you could just take away 3, and I'd give you 3. And that give you 4.
And you add 1, right? Or but you have to use all of the numbers.
Oh, you have to use all of them?
Oh yeah, but oh, okay, let's do this way, sorry. So this is, what about this 2 plus 1?
2 plus 1 is 3, so 7 minus.
Yes, we got 4, right? Good. Then let's get the let's get 5 using 1, 2, 3 again. How do we get 5?
3 plus 5.
3 plus, but we have to use 1, 2, 3, 4. 3 plus possibly 3. Okay, 3 plus 4. What's 3 plus 4?
7.
What's 1 times 2?
3.
Just
Wait.
no, not 1 plus 2. 1 times 2.
2.
A little bit we use multiplication, but still we will continue doing this one. Yes, that is the, so this is the maybe this problem I start this problem. This problem will be your homework. Homework for how do you, what it would be the smallest number you can create, if that's so. Yes, that's all for today. Sarah, do you want to ask any question? So, yes.
Yeah. Could for getting the answer, could you take apart 9 and make smaller numbers?
Yeah, but you have to use 3-digit number, right? But let's say you need to use, let's say 900 or 800, something like that, right? Let's say 974, 860, maybe 5, something like that. You need to make it very smaller. Let's see how small you come up. Then there will be only one the smallest possible difference. But you will find, I think, 2-digit smallest possible difference. Yeah, you just try your all the number best, or to make it smaller. Maybe that's the one hint. Could be 600 something 500. Because you want to.
Can I quickly do something really quick, please?
Yes.
I just needed.
Okay, you can just copy down this one and then just work on, because this problem is it's called open middle. It's you need to really try to get the smallest difference, but you need to just use once.
I used snipping tool to copy it. That's fine.
Yes, sure. That's good. Yeah. Okay. So we did problem related to addition and subtraction. Thank you for listening and participating. Then what do we say?